We're about to dive into one of the biggest mysteries on our planet, a place we once thought was completely lifeless. But what we found there, well, it shatters everything we thought we knew about the limits of survival. For centuries, we just assumed the answer was nothing, a sterile, crushed, frozen desert. We sent a baited camera more than 10 kilometers down into the Mariana Trench, pretty much expecting to see an empty wasteland. This is not emptiness. This is chaos. Instead of a desert, scientists found a boiling, writhing ball of amphipods, think deep-sea piranhas, absolutely tearing the bait apart. This one image completely destroyed our entire understanding of where life can exist. To get what's going on here, you have to understand their world, the Hadal Zone. It's named after Hades, the underworld, and for good reason. The pressure is so immense it would crush a modern submarine like a soda can. So the real question becomes, how does anything survive this? And that right there, that's the central mystery we are going to crack. The answer involves a bizarre biochemical limit, isolated islands of evolution, and a secret ingredient that rains down from our world. You're going to want to stick around because the final reveal will absolutely blow your mind. What's incredible is just how recent all of this knowledge is. Think about it. Before these dates, we knew more about the surface of the moon than we had actual proof of life this deep. We are truly in the golden age of Hadal exploration, and it all started less than a century ago. Okay, so how on earth do they pull it off? The first piece of the puzzle is in the truly bizarre creatures that call this place home, and figuring out how they deal with having a skyscraper's worth of weight on their back. At these depths, the water is so corrosive to calcium carbonate that building a hard shell or a skeleton is pretty much impossible. This sets up rule number 1 of the Hadal Zone. You gotta be squishy. That's why we see tons of soft sea cucumbers and shellless crustaceans. But this creates a fascinating question. Where are all the fish? Well, it turns out there's this invisible, unbreakable biochemical wall that fish just can't cross. To fight the crushing pressure, they flood their cells with a stabilizing molecule called TMAO. But it's a deal with the devil. The deeper they go, the more TMAO they need. At about 8,200 meters, the concentration becomes toxic, essentially making their internal fluids as salty as seawater itself, and life becomes impossible. And here is that limit in action. This is the snailfish, filmed at over 7,700 meters deep. It's one of the deepest living fish ever found, pushed to the absolute ragged edge of where its own biology will let it exist. Any deeper than this, and the ocean becomes a no-fish zone. Okay, so we've got squishy creatures and a fish-free zone. The second clue to this whole mystery is the profound isolation of these trenches. They're not just deep, they're prisons. The very same adaptations that allow these animals to survive the extreme pressure also trap them there. If they tried to swim up to the shallow, abyssal plains at 4,000 meters, the lack of pressure would be just as deadly as too much. So each trench becomes a lost world, completely cut off from the others. And the result of this isolation? A staggering level of endemism. Over half, 56%, of the species discovered in the Hadal Zone are found nowhere else on Earth. They are unique to their one specific trench. This is evolution on fast forward, in complete isolation. So we have these soft-bodied prisoners trapped in their own isolated worlds. But what are they eating? This brings us to the final and most important piece of the puzzle, the food source. To figure this out, scientists compared 2 trenches. You've got the New Britain Trench, which is close to land with fertile waters, and then you have the Mariana Trench, out in a remote ocean desert. The question is, does what's happening on the surface really matter 11 kilometers down? The answer is a resounding yes. This chart shows net primary productivity, which basically just means how much life is there in the sunlit waters way up above. The water over the New Britain Trench is almost 3 times more productive than the water over the Mariana Trench. That's 3 times more food being created at the surface. And that difference at the surface has a direct, dramatic impact at the bottom. The food-rich New Britain Trench has double the animal abundance and 3 times the variety of scavengers. They even found things like coconuts and palm leaves on the seafloor. The Mariana Trench, by comparison, is much more sparse. The link is undeniable. Okay, we've got our pressure survivors, our isolated islands, and a food source from above. Now, let's put it all together for the big reveal that answers our central mystery. This is the core concept. We've been thinking about trenches completely wrong. They're not empty pits. Their steep, V-shaped geography turns them into giant natural funnels. Scientists call them Depocenters because they actively trap and concentrate any organic matter that sinks from above. So, this secret ingredient for this thriving ecosystem isn't some weird chemosynthesis or alien metabolism. It's us. Or rather, it's the leftovers from our world. It's a constant, slow-motion rain of dead plankton, carcasses, and yes, even trees that fuels this entire hidden world. And now for the scientific mic drop moment. That remote food-poor bottom of the Mariana Trench, Challenger Deep, we sent probes down expecting to find sterility. Instead, we discovered it's a hotspot for fungi. The decomposers of our world are thriving down there. But why? This complex-looking analysis is the smoking gun. Don't worry about the details. What this chart shows is a direct link between the types of fungi found at the bottom and the organic matter available. Things like carbohydrates from plants. Basically, the same kinds of molds you might find on old fruit or bread are down there, having an absolute feast on the organic trash being funneled into the trench. So here's the bottom line. The abyss isn't empty. It's a recycling bin. A highly specialized, high-pressure, totally dark ecosystem that has evolved to thrive on the constant rain of debris from the sunlit world far, far above. This completely reframes how we see our planet. The most remote alien world we know is right here, and it's powered by our leftovers. It makes you wonder, what else is down there? And what other impossible life is just waiting for us to look in the right place?